He doesn't know what.
No way. I don't. You're an adult. Yeah, exactly. Why am I playing to say I'm done?
All right. We'll go ahead and get started with our notes here. Do you have a question? Yeah.
Do we need a calculator?
Yeah, you'll want a calculator. If you need a calculator, come grab one from up at the front. But you will definitely. Oh. So we're going to go ahead and get started here. A lot of what we're going to be covering at first is going to be terminology. We're actually going to find that that is a fairly large kind of barrier to entry here, as I suggested it might, that linguistic element. Goal, though, is to kind of get a feel for a lot of kind of the work that we are going to be doing, a lot of the methodologies that we will see with statistics, with a topic that you guys are already very familiar with. This is something at the very least that you would have seen in Algebra 1, probably also something that they revisited in Algebra 2. And we're just going to be taking a look at it from a maybe slightly more refined, maybe not even, kind of stance where we will really kind of dive into and uncover what is going on here. In particular, what we are going to be concerning ourselves with are scatter plots and the correlation between two variables. We're going to start with the idea of correlation. Very much kind of inherent in what we are going to be doing, particularly with this kind of first section, is we are going to be trying to make some kind of connection or analyze some kind of connection that we see between multiple variables. For instance, the example that I really like to fall back on over and over again, what happens to murder rates in an area when ice cream sales are up? Or maybe a little bit more obviously, what happens to attention span when someone with ADHD takes more ADHD medicine? Or what happens to the height of an individual when you arrange them by age? Or what happens when we are comparing the amount that someone, number of steps that someone walks in a day with something like their reported happiness. Things that are essentially comparing one measurement to another. Now, the variables themselves are certainly things that we could do statistics on alone. It is perfectly reasonable to do a full statistical analysis on what on earth is going on with ice cream sales in a various city or in various cities. That is totally fine, and there is information that you can gain from that. But intrinsic to what we're going to see with correlation, these are always going to be off-putting one variable from another. Sometimes we'll see that this is experimental, sometimes it's not going to be, and we will just have to roll with the punches. The correlation itself, for our purposes, is going to be the relationship between two or more variables. Now, it is totally possible for us to look at a correlation between 3 or 4 or 5 or 6 variables. That's totally fine. Often, especially for visualization purposes, especially for this kind of like intro statistics class that we're going to be running through, we're really only going to be comparing 2 variables. Even if I were to give you a set of like 6 different variables to look at, you would say compare variable A to variable C, and then compare B to F, and then compare C to D, and then A to F. You're not really going to do like a wholesale, let's compare every single trend that we see for every single variable all at once. Generally speaking, you're going to pick apart and compare 2. That's really where we are going to feel the most comfortable, particularly with kind of some of the graphing limitations that we have. As far as what we are actually gaining from this comparison, we are going to define the regression as pieces or descriptors of our correlation. This is descriptors. The ones that we are going to see, especially kind of this early on, 3 main ones. Is our correlation positive or negative? Is our correlation strong or weak or moderate? And is our correlation linear or anything else? And when we ask that question, we really just hope that it's linear, because if it's not, they're like significantly high. As far as the types of relationships that we could possibly see with our correlation, again, our bread and butter is going to be the simple relationship, which is just a comparison between, or a relationship between 2 variables. And a multiple relationship, which logically is going to involve more than 2 variables. More than 2. We're not really going to talk all that much about like the simple relationship versus like, is what we're looking at a simple relationship or a multiple, just to kind of get you familiar with some of the terminology here. You will certainly want to know, if I ask you to tell me about the correlation, what I'm asking for. We are going to use the word regression to describe a process that gives us information about the correlation. So again, having that is useful, but most of this is just to kind of get us up to speed with what are the tools that we're looking at. All right. Couple of types of variables that we could see. We're going to actually find that these definitions aren't quite as all-encompassing as what we've seen before. Certainly, we have talked about independent and dependent variables with regards to functions. That is kind of a very common place that those turn up. It's not going to be quite that simple. Very often, it's not going to be quite that simple. And it's a little bit actually tricky to fully encapsulate what we're trying to talk about with these independent versus dependent variables, because they generally don't have to do with correlation and instead have to do a little bit more with causation. The difference between those two we'll flesh out in a couple of days. For our purposes, the independent variable is often going to be a piece of, say, like a study or an experiment. And it is most often the variable that we are controlling ourselves. An example could be if we are, say, watering plants to see if watering a plant more causes it to grow more. The amount of water that we give the plant would be the thing that we are trying to control. And since it is the thing that we are trying to control, that would be the independent variable. The dependent variable is the variable that we are expecting to be influenced by the independent variable. In the case of my watering a plant example, we would expect watering a plant more to maybe cause the height to grow more. With a certain amount of watering, except maybe it's not quite so linear. Maybe after we overwater our plant, then the height starts to decline again, and we get maybe some kind of like bell curve shape. But we would expect that height variable, the other kind of piece that is changing as a result of us watering, to influence, to be the dependent variable. That would change as a result. Now again, it's not going to be quite that clean. And even in this example that I have kind of contrived here, you could very easily say that, hey, maybe a person is more likely to water their plant if their plant isn't growing as well. So the course code is going to be whatever like lore when you go into the student code.
Sorry to interrupt.
You're totally good. So if you go into Pearson here, this is the course ID up at the top here under the student courses, and then that will be the access code that they use to get in.
This one.
Yeah, so that's
they
the
don't need
access
this one,
code.
any
They
of
don't need
this.
anything here
Okay.
other than the access code, and then the course code, the course ID is going to be whatever this little thing is. So it'll be Elliot, some numbers. Yeah.
Thanks.
Yep. So even in this example, it's not super clear cut, because you could also imagine maybe a poll rather than a study, where we ask people based on the height of certain plants, how much water they would give the plant. All of a sudden, the height of the plant is influencing the amount of water that is being given to the plant. And so all of a sudden, this whole independent-dependent relationship that we're seeing is completely thrown out of whack. Now you'll notice the key difference here is that it wasn't a study that we were talking about at first, that it was an experiment that we were running where theoretically we would be holding constant all sorts of other parameters. There isn't really like human choice involved of, oh, I'm going to decide whether or not I'm watering more or less. And so often when we are referring to independent or dependent variables, these are very largely going to go hand in hand with some kind of experimental data. In particular, the independent variable is going to be the experimentally controlled variable, kind of. And the dependent variable is going to be the variable that changes as a result, or rather that we are trying to measure. Generally speaking, when we are talking about variables, we are going to refer to either our x or our y. What do we normally use for the independent variable? So you'll want to go into the active student courses. and copy this course, and you'll create a student course, and then that will have the ID.
Thank you.
Yeah, of course. Yeah, so normally the independent is going to be the X, and the dependent is going to be the Y. We plug in the X value, and we look at what happens to the Y value for a particular X value. Often we are less concerned with finding an X value that goes to a particular Y value, but certainly we are capable of doing that as well. So looking at the kind of first example that we were given, in terms of medication, we'll maybe say that this is like dosages of medication and the cholesterol level. What would we maybe say as being the independent versus dependent variable between the amount or the dosage of medication and that person's cholesterol level? What is going to kind of influence the other one by changing it?
The medication would influence the cholesterol level.
Yeah, we'd expect the medication to have some kind of impact on the cholesterol level, and so the medication is going to be the X, and the cholesterol level will be the Y. But again, not super clear cut. Right? This would need to be a little bit more elaborated upon in order for us to really make this inference. For instance, what if instead of an experiment where we're controlling doses of medication, we are instead doing a survey where we ask people both the amount of medication that they take and the cholesterol level that they have? We might instead find that having a higher cholesterol level causes more people to take more medication. So the higher their resting cholesterol level is, having some kind of impact on the amount of medication they take. In a different context, the independent and dependent variables can be completely switched. I think this is the most obvious. This is what I would default to, given this, is that the medication is the X and the other is the Y. But really, I want it to be kind of clear that often these are very interchangeable, that we're looking at different things when we switch them around. So it is important to know what is the X, what is the Y, what are we implying with this? And then sometimes this kind of labeling is just completely useless. Like if I'm looking at number of ice cream sales and number of murders in a particular area, which one is going to be the independent variable, which one's going to be the dependent variable? It doesn't really make sense to say that there's a causal link between two. Why would buying more ice cream make people more stabby? Why would stabbing more people make people more inclined to buy ice cream? It doesn't necessarily have that same kind of link to it that we might expect something a little bit more direct, like medication and cholesterol, to have. Sometimes these X and these Ys are just arbitrarily assigned and can be reversed. Often, to clear that confusion, I'll tell you which one is X and which one is Y. Also often, to clear that confusion, part of the process will be you telling me on your graph, on your label, which one is the X, which one is the Y, which one represents which. Questions? All right. A couple more things before we finally get to take a look at a couple examples. Well, one more thing really. So correlation, a lot to do with, again, these connections between these various variables. And the way that we are often going to visualize these correlations is through use of a scatter plot. What is a scatter plot and why is it different than, say, just like a normal graph of a function? What makes a scatter plot special? What's a scatter plot?
Oh, okay, I thought you were doing something.
It's like when the points are like kind of all over.
Yeah, so rather than having a normal kind of curve, right? Rather than having like a nice connected either line or a nice connected who even knows what, we instead are just plotting data points. Actually, very, very straightforward. Think of a scatter plot as very simply just plotting. I'm going to describe them as disjoint, just to kind of hammer in this idea of we're not trying to connect the dots. We're not trying to do anything with the dots. We're just putting up the dots. That's all we're trying to do. So plotting disjoint data points that will often be given in the form x, 1. And nothing else. We're not trying to, again, we're not trying to make connections. We'll see, we'll have a couple of tools that allow us to use the scatter plots and draw something akin to connect the dots, but largely the connect the dots itself is something that we actually very deliberately want to stay away from. As far as creating the scatter plot, it's very, very simple. You're just individually plotting the points that you are given. Again, you are not connecting them. So for instance, if I was given the point 1, 1, maybe given the point 2, 2, and then maybe given the point 1, 4 on my scatter plot here. Just to be keeping good practices, we'll label my x and my y, and we just plot these as points. So plotting the point 1, 1, plotting the point 2, 2, and plotting the point 1, 4, not making any attempts to connect anything, not making any attempts to do anything other than plot the x and the y. The example that I've given here is with these just nebulous numbers, having an x value of 1 doesn't mean anything to us in this context. Having an x value of 2 or a y value of 4, those don't really mean anything. Generally speaking, in something that you want to get into a really good habit of, if this stood for something, like maybe 1 is number of ice cream sales for the x, and this 1 is the number of deaths for the y, then you would want to label that on your scatter plot. So if this is ice cream, and this is deaths, then you would want to make it clear that that is in fact what you're referring to, and you get a completely different scatter plot if you use one for the y and the other one for the y and the other one for the x. Not that the other scatter plot that you get is wrong. It's also a completely valid way to represent the data. There's, again, nothing incorrect about it. It just would be a different scatter plot. You want to make it very clear what you are using as your expectations. Little things like that will get you dinged, unfortunately, pretty heavily. So just trying to build some good habits. These aren't particularly hard to do by hand. We're also pretty much never going to do them by hand, which, again, is going to be a lot of what this class is. So, for instance, taking a look at this first example here, we're trying to construct a scatter plot using the kind of data that we are given. We could certainly talk about like causation and all of that. And that would probably be fine if you wanted to be like super precise about like what should be the independent and what should be the dependent here. We certainly could talk about it. I would say the number of hours that we work probably causes us to have more sick time. But you know, you can make an argument, I think, either way. Again, a lot of this is nebulous. Just making sure that we are being very clear what is our x, what is our y. You could reverse this as well. And again, you'll get a different scatter plot, but also one that we could certainly use. And we could go through and graph these by hand, but again, we're never going to do that. So on your calculators, they're going to be your best. And it's possible that this is already set up. But if you have a fresh reset calculator, you're not using one of the classroom set. What you are going to do is you are going to go into the stat option, which is just to the left of the arrows, and you're going to go to edit. These tables are where you are going to input your data. Ultimately, it doesn't really matter what list you use. You just kind of need to keep track whether you're using the first list as your X or the second. It doesn't really matter. You just need to keep track of it. The easiest way and the way that the calculators are really preset to handle is you probably want the first list to be your X's and the second list to be your Y's, but there are ways to deal with it if you reverse it. That's totally fine. And so all you're going to do is take this information and put it into the various lists. Well, I guess not all, but the starting thing, taking the information, putting it into the various lists. Making sure that you have two separate lists for the X and the Y. And once you have your data entered, once you have your data entered, you are going to go to equals. You're going to go to second Y equals. And you're going to want to make sure that at least one of these plots is turned on. It doesn't need to be the first one. It can be any of them. But the easiest is probably just to make sure that the first one is on. If you are using a classroom calculator, it probably already is. The other thing you want to make sure is that the X list that it is pulling from is what you used for the X list, probably L1, and that the Y list is the Y list that you used. The default is L2. You can change those. The way you change those is if you hit second 1, it will pull up L1. If you do second 2, it refers to L2. You want to make sure that we are, in fact, graphing a scatter plot, so we're not trying to connect them like what we see. We're not making a histogram or anything like that. Making a scatter plot. And then you are going to go to Zoom, and you're going to go to Zoom Stat, and that will pull up your graph. Your scatter. If you were then graphing this on paper, the only thing that you would really want to make sure of is that you have some kind of gist of axis labeling of maybe denominations by 10 or something for the denominator, maybe by 1 for the numerator, getting it about right. More importantly though, you'd want to make sure that, for at least how I did it, that the x-axis is labeled as hours and the y-axis is labeled as symptom. That's really the important thing here, is making sure that your labels are correct. And you're more than welcome to graph it by hand, but also these are your notes. Do whatever you want. All right, questions for me with our scatter plot? Yeah, absolutely. Okay, here's what we're going to take a look at our second example here. So I think this is page 4. Don't worry about doing it by hand. I want you to focus on the technology element of doing these in here. Clearing the lists can be a little bit annoying to do it by hand. You have to hit the delete button over and over again. That's fine. You can also go to stat, clear list, and if you do second L1 to clear L1, then it will clear L1 automatically. Stat, clear list, second 2 will clear L2, and then you can enter it. You can also enter it on top of it. Yeah, you can also just enter it.
Do you have to enter it in biggest?
No, doesn't matter. No, it's actually really, really nice, and you don't even need to mess with the order or anything. Okay. So go to let's go to stat. So this looks good. This on. Looks good. Stat. Oh, it doesn't like, okay, so it doesn't like what's going on in your like y equals here. So we just like clear all of these, and then try, so then zoom stat. Because it grabs both of them at the same time. We're gonna take advantage of that, but yeah, if you have anything messed up in the y equals, it'll also show. Yeah. Okay, so if you want to pull up the list, you're gonna go stat, and then edit. And so those are your lists that you're looking for. So it should correspond to what's like the person. So just kind of this one, which is good.
Dude, that's not me.
And so then we're going to go to second. Because someone's already done this, it's going to be on, but just to make sure. Notice here that it says that the plot is on. It also has this plot on. You don't need both. You just need one. So since this plot is on, we're happy. We're going to go to zoom. Go down to zoom stat. Focus in on just that. And that's technically that's like 2 of them. And then you would draw. Yeah. And just make sure that you're labeling what's your X and Y. Yeah, that's perfect. Very nice.
I don't know, I just do, I would like to say.
That looks good for the posters. Yeah, that looks right. All the examples, that's perfect. And then just like when you're making sure. Actually, absences here probably.
You're the toilet and he moves that.
That looks good. Very nice. And just like when, if you were to actually or something, you would just want to make sure. Perfect, perfect.
And like they stuck around.
It's probably
I think I'm complaining. I just so like. I or not, but like I don't know how to run off and go down this.
This looks right. That looks great. Perfect. And you can do this, just for yourself, really points, and just making sure you.
Oh, wait.
You
Yeah,
can.
every single class that I've gone to, I lived it.
And then I would just do like just like a rock, it doesn't need to
And
be
then I have.
just like a rock that here's about where.
There's still like people. And the hallway is like.
So you go to
And people are walking.
stack and then list, and then second. And then, 1, 2, or whatever. You can also.
Oh, this is do with the test and then back to like that.
Question or just?
Why? Don't worry about it.
Cool.
That's just the part
Yeah, so you would, this would be your. And then.
I generally don't, I know it'll be fine, but I like to still.
Okay, so that could be actually.
So then you're gonna go, just make sure that it's on. You don't have to do this. You know, it's on. So second.
It's nice because I can always.
Notice how the first is off. One out, two.
But they.
And then nine.
But like my teacher was
No,
like.
I had the zone shit before the.
I don't know.
All right, so you guys should be able to, at the very least, start some of what is on the classwork if you would like to. We'll have plenty of time to knock it out, so not all that worried about that. If you have any questions for me, one thing to kind of highlight, my email is C1 Burgess. The band director got here like a month before me, and so she got C Burgess. Not that we're bitter about that, but C1 Burgess, unless you want to ask the band director about any math-related questions. One quick thing to note as well, and this is again part of what this is kind of part of what the school is doing. They're really cracking down pretty hard on early dismissals. And also, this is just kind of a policy for me. It triggers my anxiety when people start crowding around the door, because then I feel like I have to be monitoring people. So if we finish early like this, which there'll be plenty of days, and you'll generally have something to work on when we do. But when that is the case, just sit tight until
These are my running shoes.